Good day, ladies and gentlemen, and welcome to Tembela Maths Club. And today we are going to be doing Introduction to Trigonometry. And my name is Mkondisi Macaba, and I will be running this session. Ladies and gentlemen, I am coming from Tembela Maths Club, and we believe that there exists a solution. We believe that in all the maths problems that you have, there is a solution. And then today we're going to be sitting with you, we're going to be pondering, and we're going to be exploring some of those solutions for the problem that is currently in front of us, which is a problem in trigonometry. Ladies and gentlemen, let's get this party going. But before we get this party going, I want to bring some wise words for you, and these wise words come from Paul Helmos, and he says the following, and I quote. He says the only way to understand mathematics is to do mathematics. And I repeat, the only way to understand mathematics is to do mathematics. Ladies and gentlemen, personalities, I agree with this notion that the only way to understand mathematics is to do mathematics. So ladies and gentlemen, watch this video and practice and practice. If you have to stop this thing and practice yourself, do exactly that the way you want it to be. Now let's go. Now at the end of this session, you should be able to understand the following. There are 4 things. Number 1, the need for geometry. Number 2, basic trigonometric ratios. Number 3, using trigonometry to find a missing side. And then lastly, using trigonometry to find a missing angle. Now, ladies and gentlemen, let's say you are given a problem like this, and you are requested to find side A and side B. Now, how will you go about solving this problem? Now, I want you to think about it. You can pause the video if you want to and start thinking about it, and then resume afterward. But ladies and gentlemen, can we use Pythagoras theorem? Because when we see a right angle triangle, something that comes to our minds first when we think of that word is a Pythagoras theorem. All right? Now, can we use Pythagoras theorem? Now, Pythagoras theorem has 2 conditions upon which it can be used. It can be only used if these 2 conditions are satisfied. Now, the first condition is that it must be a right angle triangle that we are dealing with. And then in this particular case, you can see this is a right angle triangle. So yay, maybe we can use it, but hey, we are only given this side. Pythagoras theorem can only be used if you are given 2 sides of the right angle triangle. But this time around, you are given this side, and then you are given this angle. So it is one side that is given. So now what are we going to do in this case? It simply means that the new theory is required. We need a new theory so that we can be able to look at this. Now, what is that theory? That theory is trigonometry. Yes, that is a theory that comes to our rescue. Now let's look at trigonometry, ladies and gentlemen. Now you will have a triangle like this, and then in this triangle there is this angle that we call theta, and then there is this side with O, and then this one with A, and this one with H. Now what do these things mean? Now ladies and gentlemen, this is what we use to explain trigonometric ratios. And when we are talking about O, that is the opposite side. So when you are sitting here or when you are standing here looking directly, there is a side that is opposite to you, that is denoted by O. Now, this O simply means it's opposite to theta, which is the angle. And then H stands for hypotenuse. That means that it's the longer side, or the side that is opposite to the 90-degree angle. It's called hypotenuse, and it's denoted by H. And then lastly, there is an adjacent side that is denoted by A. Now, we are going to use this to define trigonometric definitions or trigonometric ratios. Now, these 2 words ladies and gentlemen, trigonometric definitions and trigonometric ratios, we are going to use them interchangeably. But basically, a trigonometric definition is sine theta. Now, when it comes to ratio, the ratio is something divided by something. So the ratio is, for example, if you've got opposites over hypotenuse, now that is a ratio. Now, when you combine all of those things together, it's trigonometric ratios. Right. All right. Now, when you define the trigonometric functions, you will get the trigonometric ratios, and then you will get sine theta, which is equal to opposite over hypotenuse, and then you have left cos theta, which is adjacent over hypotenuse, and then you will get the tan of theta, which is opposite over adjacent. And people usually do this when they want to remind themselves. They will use something called SOHCAHTOA, and then this S is for sine and it's opposite over hypotenuse, as you can see here on top, and then this C is for cos, which is adjacent over hypotenuse, as you can see here, and then lastly the T is for this tan, which is also opposite over adjacent, as you can see here. So this is an easier way that you can remind yourself about these trigonometric functions and their related ratios. Right. Now, ladies and gentlemen, let us look at these trigonometric ratios now in context. Right. So what will happen is we have this triangle, and then we've got these numbers, and then when you look at sine theta, it's opposite, and then the opposite number here is 4, which is this one, and then the hypotenuse is 5, which is this one. And then you'll have cos theta as well, which is adjacent over hypotenuse, which is 3 over 5. As you can see, adjacent is 3 and hypotenuse is what? Is 5. And then lastly, you'll have tan theta, which is opposite over adjacent, and the opposite one is 4, as you can see here. And then the adjacent is 3, as you can see, this 3 here. So it does correspond with what we have been learning. Right? Now, let's go back to the original problem, because we're doing all of these things so that we can be able to understand the logical problem. We're given a triangle like this one, and we're requested to find A and B, right? So how are we going to go about doing this? Now, when we look at this, we need to find something that connects the angle that we are given and a side that we are given and what? And another side that we are given. Now, when you are standing here, it turns out that what you are looking for, because in that formula you must have what you are looking for, and you must also have what you are given. What you are looking for is A, which is an opposite of this angle, and then you are also given you are given an hypotenuse. You are looking for opposites. You are given a hypotenuse. So it's OH. Now, what is the formula that has OH? Aha, it's sine theta. So sine theta is equal to opposite over hypotenuse. So that is why in this particular case, ladies and gentlemen, we are going to use sine theta. Now, immediately after that, what we are going to do, we're going to substitute sine 31 degrees, this one, which is equal to A because we do not know it, divided by 17 because we already have it. And then we are going to cross multiply. So this multiplied by this is going to give us 17 sine 31 degrees. And then this A times this one is going to give us A. And then when you put this thing on a calculator as it is, and ladies and gentlemen, make sure that your calculator is in degrees when you are doing this kind of things. So when you put this into your calculator, you will end up with something like this, where you'll have A, which is equal to 8.76 meters. Right, let's continue. Now, what about B? How do you find B? Now, when you are standing here again, remember we said the formula should have two things. It should have what you are looking for and what you are given. Now, what are you given? You are given this and this, and then you are looking for B. Now, when you're looking at the sides that is given and what you are looking for, there is what? There is the adjacent side. There is also a hypotenuse side. So what is the trigonometric function that has both the adjacent and the hypotenuse. It's AH. So what is it? It's cos theta. So cos theta is equal to A over H. And then our substitution will then substitute this 31 degrees here, and then substitute this B here, and then 17 here. And then we'll cross multiply it in the same way as we did here. And then we'll get something like this. We'll get 17 cos 31 degrees, which is equal to B. And then at the end of the day, we are going to get, so they are saying A here, we are going to get B. It's not A, is B. Let us sort it out. Let's fix it. Let's fix it, ladies and gentlemen. When there is a problem, what must we do? You must fix it. Okay, where is this thing? There we go. There we go with a pen. This must be B, not A. B. Aha! There we go. We were able to fix it. Now let's go on, ladies and gentlemen. Now, what if we are looking for an angle? What if we're giving something like this? And now we're no longer looking for a side, we're looking for an angle. Now, how do we go about doing this? Ladies and gentlemen, we do the same thing. We are noticing that we are given two sides, and relative to this angle, this is an opposite side, and then this is an hypotenuse side, right? Now, because this is an opposite side and an hypotenuse side, that means it's sine, which is a trigonometric function that has those sides. So what we're going to simply do is we're going to say sine theta is equal to opposite over hypotenuse, and then we know that our opposite side is 1, and then our hypotenuse side is what? Is 2. Now what we're going to do now is we're going to make theta to be subject of formula, and then we'll have theta which is equal to the inverse of sine, or the reciprocal of sine, evaluated at what? At 1 over, not the reciprocal, the inverse of sine. There is a big debate between reciprocal and inverse, but we won't go into that. Let's call it the inverse of sine for the purposes of what we are currently doing now. The inverse of sine evaluated at 1 over 2. And then if we put this thing in a calculator like we did earlier, and then what we're going to get is 0 theta is equal to 30 degrees. Right. All right. Now, this is how we find an angle when we have been given side using what? Using trigonometry. Right. Now, let's go more on angles. Ladies and gentlemen, you saw the earlier formula for an angle, which is theta is equal to the inverse of sine evaluated at opposite over what? Over hypotenuse. You can also use other trigonometric function. For example, you can use theta is equal to cos. You can use cos theta. So then your theta will be equal to the inverse of cos evaluated at adjacent over hypotenuse. Or you can also use what? Theta is equal to what? Is equal to the inverse of tan evaluated at opposite over adjacent. So it will all depend on what is it that you are given. So for example, if you are given opposite over adjacent, then you use tan. If you are given adjacent over hypotenuse, then you will use cos. If you are given opposite over hypotenuse, then you will use sine, as we did earlier. Right. Now let's conclude. Ladies and gentlemen, when we conclude, we want to check if we were able to answer the questions or understand things that we were supposed to understand when we opened the session, that we said that we were aiming to understand. Number one, the need for trigonometry. We saw that we need trigonometry to solve problems when we are only given what? When we are only given one side and an angle in what? In a right angle triangle. And then basic trigonometric ratios, we did them. It's cos, sine, and theta that we're going to use for the purposes of this course. And then using trigonometry to find the missing side, we did that, and we were able to do it successfully. And then lastly, using trigonometry to find the missing angle, we did that successfully. Now, ladies and gentlemen, thank you very much for tuning in, and have a lovely day further. And thank you, and goodbye.